All right, good stuff about indexes. Can you show us some more?
Absolutely. Let's take a look at a demo. Right, well, let's take a look at something to do with indexes here. And what we've got here is a table. I've created a table called sales order detail. And this is technically what we'd call a heap. There's no indexes on this table. It's just a bunch of data in a table that is stored in pages on disk. But we're not really worried about indexing it at all. So let's take a look at querying from that table. And what I'm going to do is I'm going to turn some options on. I'm going to turn on something called the statistics IO, so we can see how many pages are read when we go and retrieve data from that table. So let's go ahead and set our statistics IO on. And I'm going to set an option to show the actual execution plan. There's a couple of options up here. I'm going to show the execution plan. And what that will do is give me a visual representation of how the SQL Server query engine is actually performing the query, what it's doing under the covers to go and get the data from the table. And we're just going to do a very simple query. We're going to select the product ID and the order quantity, where the sales order ID is a particular sales order. So get me the products and the number of those products that were ordered for a specific order from this table. We'll go ahead and we'll run that. And I get back my product ID and my order quantity coming back from the order table. So it's worked, it's got the data from me. If I take a look at the execution plan here, it's kind of small, so you might not be able to read it, but you can see that we've done what's called a table scan. It's effectively just gone and scanned the entire table to find the rows that satisfy the query, to find the products and quantities for that particular order. If I just click on the Messages tab, then I can see some of the statistics that have been returned for that query. So I can see, the thing I'm really interested in here is the logical reads. That's the number of pages that were read in order to find those rows that we returned from the query. And I can see that there's 1,496 pages that needed to be read in order to find just those two rows that were returned. So that's me querying a heap. There's no index. We had no choice really but to read the entire table and just find the appropriate pages. Let's try creating a clustered index. So we'll create a clustered index. It's called IDX Sales Order ID, and it's on the Sales Order ID column. So we'll go ahead and we'll create that. And that goes and creates my index. I get the stats coming back from that. This is irrelevant. That's just what happened when we created the index. And now we're going to try that query again. We're going to try and get the product ID and the order quantity from the sales order detail for that specific sales order. And we're identifying the sales order using the sales order ID, which we now have a clustered index on. So if we go ahead and run that query, again it returns the data. If I look at the execution plan again this time, you can see it's slightly different. It does a clustered index seek. So it's actually using my clustered index that I've created. The SQL Server is smart enough to realize, hey, there's a clustered index there. I can use that to get the data. And if I look at the messages, our logical reads have gone down from 1,400 and odd to 3. So the index is very effective in reducing the number of pages that we needed to read in order to find that data. Well, let's try something else. Let's try getting the orders by product. So I want to find out all the orders where I've ordered product number 758. So let's go ahead and run that. And it brings me back the sales order ID for all of the columns where I've ordered that particular product. And if I look at the execution plan, again, it's using the clustered index. Even though I'm not filtering on that indexed value, the clustered index is still a useful way to find the pages that I need. So we're using that clustered index. And if I have a look at the messages, I can see the logical reads. There were 1,575 logical reads to get all of the pages that I needed, but we were using the index, so we got a little bit of optimization there. But what I'm going to do is I'm going to try and further optimize. Now, I can't create a second clustered index because a table can only have one clustered index. The data can only be stored, in one order. But I can create a non-clustered index. I can create a secondary index on this table, and it's going to be based on the product ID column. So again, that column that we're filtering on, we'll go ahead and create that. And let's try that same query again. This time we are going to bring back the all the orders for where we ordered that product number 758. And if I have a look at the execution plan this time, oh look, we're using the non-clustered index now. So SQL Server is smart enough to realize, hey, that's a better way of doing this. I've got a non-clustered index on the product ID. That's an easier way to find the rows that I need. And when I look at the messages here, again, our logical reads is reduced dramatically. We're back down to 3 logical reads. We've only had to read 3 pages in order to satisfy that query. And then what happens if I actually include in my, my query a non-index field? So I'm searching for the sales order ID and the order quantity, which I haven't got any index on, from the sales order detail where the product ID equals 758. So I'm still filtering on the product ID, but I'm including the order quantity this time and the sales order ID. So we'll go ahead and run that. And I get back the sales order ID and the order quantity. And if I have a look at the execution plan for this one, well, this time SQL Server has made the decision to use both indexes. It uses the non-clustered index because we're filtering on the product ID, so it goes and filters on that. But it's also then using the clustered index to do the key lookup to find the order quantities. So we're taking advantage of both of those indexes as we run that query. And again, if we look at the scans, there's 829 reads, so a few more reads because we're bringing back more information. Some of those reads are pages from the non-clustered index, and then we're using that to find the appropriate pages in the clustered index that we then use to go and get the order quantities. So there's an intelligent engine underneath that is using those indexes to reduce the number of reads and optimize the query performance as best it can.